Kia ora, tēnā tātou katoa. My name's Shane Clarke. I'm the General Manager here at Nuralite. Welcome to our webinar. I'm joined by Scott Squire, our Specifications Manager here at Nuralite. So a bit of a smaller panel than normal. Morning, Scott. How you going?
Hey, Shane. Good. Fancy seeing you here.
Yeah. No, that's great. Right, so just a little bit about our webinars before we start. This webinar's been narrowed down to 30 minutes, so there should be time for a bit of a Q&A at the end. So feel free to use that question function at the bottom there, and if we get a chance, we'll answer your questions towards the end of the webinar. This webinar is approved by NZIA for 5 CPD points, along with about 20 other webinars that we've done previously, which are available on our website if you want to, if you're in need of your CPD points or you're just wanting to further your education in this space. So this webinar will try and make it a bit interactive. So like I do encourage you to use the QA function. We'll run a couple of polls to keep you all interactive. So today's topic is on cost-conscious design. It seems to be very topical for the last few months. We've seen a lot of feedback in the industry on cost-related issues, so we thought it'd be a good idea to put together just a brief webinar to try and sort of outline some advantages that can be gained and some cost savings, of course. So before we kick off, we just run a quick poll just to see if anyone's ever been affected by a project that has run into cost issues. If it's going to run that poll. So feel free to fill it in there, and we'll share the results just to see who's in the room. Okay. Yep. As we suspected, yep. Very high number there of projects that have gone on hold due to costs. So this is why we think today's webinar may be important to the audience. So like I said, today's topic is about cost-conscious design. And we think with our sort of 50 years in the industry and in construction, Nuralite can illustrate some clever cost-saving products and systems, or what we call real value engineering. So value engineering is a term that kind of does my head in. What we're typically seeing in our industry when it comes to value engineering is cheap product swapping, if you like, with a much lower performing system than that was originally intended by the designer. Worst case scenario, these cheaper swap outs result in cataclysmic failure that end up being a lot more expensive than the original anyway. So it's the one key message that I want you to take away from today's wee chat is that we believe that true value engineering occurs at the design stage. Earlier the better. You just can't get us involved too early at all. So to show you that true value occurs at the design stage, we're going to show you our experience on this topic and basically how we've progressed from what we've done historically to how we do things today. We will then go on briefly to illustrate several Nuralite's options for cost-conscious roof systems. And then finally, we're going to run through an example of why it's never too early to engage with us. I just want to kick into the first slide there, Jay. Right. So we'll start at the start. So what we're looking at here is what we call a historical or a traditional roof build-up, depending on how we're designing. Typically, in New Zealand, we build with timber framing, lightweight timber framing, and a plywood substrate, and then a single ply membrane. This has been your experience too, Scott?
Yeah, absolutely. Yep, really typical, common Kiwi construction for sure.
Yep. So right up until 2008, it was permissible to use a single layer of membrane on plywood. Funnily enough, times have changed, and for the better. People are wanting higher performing roofs. We're wanting continuous insulation. We're wanting higher insulation. We're wanting more robust membrane systems. And what had been occurring is we've been basically putting these improved systems on top of historical or traditional type structures. This was starting to obviously increase costs because we're adding more. So what we're trying to highlight in the next slide is there's actually a better way to do it if we look at the whole roof holistically.
Yeah, and as an example, Shane, so the previous slide, that image showing all of the timber framing, it's pretty significant there. So the labor, the material cost is quite involved. And then flicking to that render, Jade, that you had. Yeah, so showing this is a cold roof, cold membrane roof build-up. And the example that we wanted to give you is, it would have been probably 18 months ago, a couple of years ago. We had the principal of an international architectural practice reach out to us regarding his own apartment building. The original design intent was essentially to design and construct the build-up that you can see here. So it's membrane on plywood, supported on framing. Now, E2AS1 requires the framing at 400 mil centres. Our 3PM system, it's code mark certified, which requires framing at 600 mil centres both ways. The approach that you can see, there's a couple of pitfalls to it, or challenges, I guess, obviously thinking about labour, material costs of that supporting structure. It's quite involved. We know with the new H1 roof insulation requirements, we're seeing much higher levels of insulation required. So we can see in this render here, you've got lofted insulation, fitted between the framing. You can also see that we've got a little proprietary mushroom vent, a thing called a Neuravent there, which is essentially designed to promote cross-flow ventilation of that cold roof. Because, with the new H1 changes, we've got so much more insulation in there, which is great in terms of reducing energy loss through that roof. But the unintended consequence, which was raised by MB, obviously there's less drying potential in that layer. Therefore, the risk of interstitial condensation is just so much greater. And often that's something that can fall by the wayside a wee bit. It's definitely becoming more topical. There's a lot more education, a lot more awareness, which is great. But the example that I mentioned, the owner, the architect, ended up adopting a warm roof system on a metal tray, which, Jade, if you can just flick to that next render. So that's essentially what was adopted. Now, the benefit of the metal tray over the plywood is that framing, you don't need supporting structure at 600 mil centres. In fact, the purlins for that metal tray could be set at up to 2.7 metres internal span. End spans is less, you're looking at about 1.8 metres. But that metal tray, coming back to the focus of this webinar, thinking about how can we design, how can we build roofs that are more cost conscious, that's by far the most cost-effective substrate to use. And the other benefit, obviously, with the warm roof, you're putting the insulation outside of the roof structure, which is where it should be, really. You're eliminating the risk of interstitial condensation. And you've also got a really good uniform layer of insulation there. And you can also see in the build-up, we've got an independent vapor barrier. Now, obviously that metal, once it's installed, fast to install, the top of the metal then gets primed and the vapor barrier goes down. Now, once that vapor barrier goes down, essentially the building's watertight for construction. So in terms of construction program, the efficiency on site, it's just so much better than that cold plywood membrane construction that we showed previously.
Yeah. So in this example here, Scott, this option was actually more economical than the previous concept of cold roof. Is that right?
That's exactly right. Yeah.
Yeah.
So this was adopted and constructed, and the project's now finished. So
Nice.
the speed, the efficiencies that were gained during that during construction, but then obviously worked through during the design stage where we collaborated with the designer and the building owner. Obviously, it translated to a successful project.
Nice one. Excellent. All right. Let's go to the next slide, Jade. What we're going to... Oh, okay. So, yeah. So what we're just comparing here in this slide is that that the near-therm warm roof on metal tray system, if you look at the whole thing holistically, including the metal tray all the way up to the membrane, is a lot more economical than a traditional standard cold roof, believe it or not. My experience sees a lot of cost actually goes into the construction of the timber. And obviously timber prices have risen, etc. And there's a lot of timber and a lot of time which goes into that structure. Whereas, like Scott touched on, that metal tray is incredibly economical, fast to install. So,
yep. So you know, thinking about that supporting substrate at the design point, obviously there's structural factors that come into play there, but our advice is definitely consider that metal tray, which forms part of our system. It's part of the code mark certified system for our 3PM, and then obviously we've got options for membrane on top for your weather tightness, waterproofing integrity.
Yep, no, that's right. This slide here, we're just trying to illustrate that we have multiple options when it comes to cost-conscious roof design. We're not a one-trick pony, and there's several factors to consider. One is to look at the actual membrane type, whether we're using a single layer or double layer. So factors that would sway you one way or the other is, you know, is it a suitable project to be using a open flame or not? Is it a simple rectangle project with large square meters where it's simple to lay a single ply? Is it a construction site that's going to have heavy foot traffic and therefore it should be double layer? So those are things to consider. Will actually do have an effect on the cost. Again, the substrate, whether it be a metal tray substrate or a plywood substrate or a concrete substrate, those are things to consider as well. Also, an efficient thickness of PIR board. While it's great for sales to have a 300mm thick layer of insulation, we can actually help out with the calculations and say that that's absolutely unnecessary and overkill on that building. So we can actually maximize the efficiency with the required R value that you're aiming for. Another example is...
Sorry, Shane. Just one thought there, thinking about your pathway to compliance with H1. So obviously, you know, you've got the schedule method, calculation method, or modeling the building, and we are seeing investment being made in an engineer, a consultant actually modeling the building, and therefore, you know, if you're using the schedule method, that constructed R value of R6.6, which could be considered overkill in some areas or for some builds, you know, can potentially bring that thickness down, like you say, and then there's a potential cost saving.
Yep, exactly. I mean, another example of value engineering, and I think we've got an example just a little bit later on, is to actually look at the existing roof you have. You know, it's maybe possible to rebirth or renew your existing roof and give it a life cycle, another spin, which could be the most economical option for you. But these are all just sort of things to consider, you know, membrane type, insulation, and substrates. So I think we kick into an example now. Okay, so this is an example of a real life project. This was a 1,400 square meter commercial project. The original design was 2 degrees of tapered insulation on a flat metal tray substrate with a 2-layer torch on. We looked at this design, and yes, it would work. It would be incredibly thermally efficient. It would have a very robust membrane system. However, it came at a massive cost. So we went through about 5 or 6 different iterations with the designer, still trying to aim for you know, what they wanted, the high R value and the thermal performance, and all those types of things. So to cut a long story short, we ended up saving $350,000 just in insulation alone, or it's about $250 a square meter, by going to a metal tray substrate which actually had the fall in it. So we weren't using tapered PIR, we're using flat PIR board. And then we were able to use an 80mm flat insulation board to give them the hour that they required that came out of the thermal modeling. And because this was a pretty basic rectangular shaped roof with very little detailing, it's a large flat 1,500 square meter area, the single ply TPO option proved to be more economical, as there's less laps. It comes in a sort of a 3.6 meter wide sheet, and the installation costs come right down. So that was a real life example of a project we've recently been involved with, where we sort of looked at some cost conscious options there, but still kept the durable waterproofing finish, which you probably want out of your roof, along with the performance of the insulation.
Yeah, and we're often asked, which system, the 3PM 2-layer torch on or TPO single layer membrane, which is the best. And there's so many factors that play into that, and often it's a case of we need to ask a lot of questions to learn more, and then that will often send you down a particular path. If you're scratching your head at your desk or pondering on your lunch break which membrane to use, we do have in our Nuralite flat roof design guide, which you can download on our website, on page number 50, as you can see here, we have a comparison table between the 2-layer and the single layer. And there's a whole bunch of different factors there, and it's pretty succinct and to the point. You can just work your way through it there, and that might help guide you in which direction to go. But often the best way to do that is really have a conversation with us. We're here to help.
Yep, some very good points there. So that's just a quick overview of an example where we were able to save a fair bit of money just by looking at changing the way we do the system. So I think we've got another example next. I like it.
Yeah.
So this
Palmerston,
was
Sorry, Shane. I was going to say Palmerston North Hospital roof renewal. So it's an existing metal tray structure. So obviously leaving that in place, there's if that existing metal tray is structurally sound, then it can be used as a carrier rather than ripping it off, deconstructing, going into landfill, having to install a new supporting substrate. So the image on the right there just illustrates the Nuratherm warm roof system with TPO. The profile, really, we're somewhat flexible with the profile, so we can work in with a range of different profiles. If it's a standing seam profile, then we just use a piece of infill, and then the vapor barrier goes down, the new PIR, then the membrane. But I mean, that's really just such a great utilization of an existing metal roof that needed to be upgraded or renewed, and moving from a traditional cold metal roof to a warm membrane roof, which the benefits, so we talk about energy efficiency, managing that risk of condensation. The other thing about this particular roof is obviously a healthcare project. You have a lot of plant equipment and such which goes on top, and I know it's not captured in this image, but I have seen images where there's a whole heap of plant equipment that's gone on top of that warm roof. So the PIR insulation board, in fact, it's highlighted here. We have excellent compressive strength with the PIR that we import, so we don't need a cover board like some suppliers in the market. The membrane just goes straight onto that PIR. We don't see any deformation in the board. I mean, it can withstand light maintenance traffic. And then obviously, depending on what you're putting on it, we've got a whole series of standard details with how that's managed. We have a proprietary fixing plate. It could be a plinth, a whole bunch of ways of tackling that. But, coming back to the point about cost, we've got an existing roof structure here which is being utilised, so that's great. And then in terms of not needing a cover board, it's an additional cost to cover board. There's quite a bit of labour. Obviously, there's weight that gets introduced, that can potentially lead to the existing structure needing to be strengthened. So, this is a really good example of a successful roof overlay with a warm roof.
Yeah, I mean, the other advantage with that particular overlay is they were able to maintain and keep using the space below. They didn't have to close anything down, or
For sure.
I mean, everybody knows there's a pretty tight in our hospitals as it is at the moment. But yeah, but not having to shut down and not having to decommission the area was a huge benefit in that particular job. So.
Yeah, and you sort of touched on it before, Shane, thinking about hot works or talking about sort of TPO as heat welded. There's no hot works for TPO as there is with a torch on. So, that can be advantageous with old timber buildings, heritage buildings, anything that might have cultural significance. Then TPO is a good option to consider.
Yep. No, it's a very valid point to keep in mind. So what we're looking at here in this slide is just a close-up or a cross-section of that Palmerston North roof build-up. So we had the existing standing seam metal tray, which we then placed in some insulation infills in between to bridge the gaps. We then ran our continuous aluminium vapor blocker across the entirety of the surface of the roof. We then installed our flat PIR board, and I think Palmerston North Hospital was 100mm PIR board, which gave them a continuous R value of 4.5 across the whole roof, which is thermally mechanically fixed. Does that make sense? Mechanically fixed with thermal fasteners into the roof, and then finished with that single ply thermoplastic TPO membrane. Just a quick build up there of what we did there.
Yeah, and it's probably worth noting, just thinking about durability, because membrane durability plays into the whole cost aspect as well. I mean, all of our membrane systems have a 20-year material performance warranty. The 2-layer torch on does have a potential life cycle of up to 90 years. You can actually overlay it twice in its lifetime. So after 30 years, you just put down another layer of cap sheet that then commands another 20-year performance warranty. And then at 60 years, you do another layer of cap sheet again. And, that's thinking about durability, not having to deconstruct is definitely worth factoring
whole of life
in.
Cycle cost. Yeah.
Totally. Yep.
Whole of life cycle costs. Yeah, right. All right, we'll wriggle on. We're down to a few minutes. So, so the last point we want to make is that it's never too early to engage with us. I guess, yeah. When is it too early, Scott, in your opinion?
Well, yeah, that's right. So, our cost, our invoice to you is $0.00. So to talk to us, concept stage or even during construction, post-construction, an existing building, it's never too early. I mean, concept stage, preliminary design is a really good time to reach out to us for some of those high-level conversations. We can certainly, through our experience, I mean, Shane, you and I, two people of a bigger, wider team around the country, so
that's right. Yeah.
Standing beside us is a team with a lot of knowledge and industry expertise, and there's not too many things that I guess we've collectively seen, but in saying that, every other day is different. So yeah, it's
it's never too early to engage with us. We're always happy to help. I've just got a quick example here of where we were asked to see if we could offer some cost savings on a building that was during construction. It was a commercial build out at the airport. That they'd run into some massive cost oversights that they hadn't picked up on the roof. They asked us if we could offer any cost savings. The good news is we were able to offer some cost savings with our code mark 1 degree. We were able to use a 1 degree tapered PIR board to replace the potentially originally specified cement screed. So it was a lot lighter, a lot faster, and being only 1 degree was a lot more cost effective than having to build it up to 2 degrees. But the real key takeaway point was, had we been involved early enough at the design stage, we would have been able to use a lightweight metal roof with insulation, and they wouldn't have had to have gone to the expense and time of building a com floor system that you see here that they had already built. So we were able to offer a cost saving in this example. However, it would have been far greater had we been involved much earlier in the design process. So that's sort of the point we want to highlight there. Yep, like we were saying, we should be easy enough to get hold of. There's a few of us around the place. Live chat is another great example on how to get hold of us. Should you need to get hold of us for one of your cost-conscious design considerations.
Yeah, that's a person. Peter is real. I can confirm that he is human.
Yeah.
And we each share that function. So it's a good way to collaborate on the fly for sure.
Nice one. All right, we're just going to finish up with the second poll, and the second poll is let us know if you need a follow-up around cost-conscious design, if there's anything else we can help you with. So quickly, just to recap, we hopefully gave you some experience we had on the history of construction and what we used to do and what we do now. We showed you how we can go about it. We've got several options when it comes to cost-conscious roof designs and considerations. And then lastly, we sort of touched on how early is too early. Well, it's never too early to engage with us. And hopefully that we held on to that key message that true value engineering occurs at the design stage. So let us know if there's something that you're working on, you need one of the team to yell out. And then I think we've got 2 or 3 minutes for a couple of questions. So that's it for a minute. Okay, it's not really a question, it was more of a comment from someone basically talking about the metal tray. Just another benefit that we didn't touch on was that during construction, the metal tray reduces the health and safety requirements because that becomes your work platform, I guess. So
yeah,
it's a good point. That's a question here. What compliance do you have for your systems? Should be good on that one, Scott.
Yeah, so we have code mark certification and brands appraisal for our 2-layer, the Nuralite 3PM, torch on membrane system, and TPO we have brands appraisal. So and the code mark is definitely, if you're specifying the 3PM, point to that as your pathway to compliance. That's the most rigorous testing regime there is for any supplier in the market.
Mm-hmm. Yep. I'm going to hit one here. What is the cost difference between the warm roof and a traditional cold roof? If you want to, can you bring up slide 5? That's where we were on that one. While it's hard to give exact facts and figures because every roof's different, what we do know is that in our experience is that the warm roof build-up, what we do know in our experience is that the warm roof build-up on the right-hand side is more economical than your standard traditional cold roof. Now, your exact savings and cost figures will vary depending on your site, your area, your type of roof, the size of roof, etc. Things like access. But our experience is showing that this is working out a lot more economically than a standard traditional roof. I mean, one example is that little proprietary mushroom vent you mentioned in the presentation, Scott. I mean, I know those retail for $150, and the tradesman's going to charge probably something around that again to put it in. So
yeah, by
the time you've installed a few vents, you've actually covered the cost of a lot of that PIR installation. So
yeah, and in terms of the thermal performance of the roof, the warm roof is more effective in that sense in terms of long-term energy efficiency, reducing the cost to heat and cool the building. Because we don't have the thermal bridging that you have with a cold roof, then it's long term. It's as well, definitely there's savings to be made there.
Yep. So another question here, Scott. Do we use the metal tray warm roof build up in residential buildings?
Yeah. Yep. No issue at all. So residential, commercial, it isn't constrained by the size of the roof. We see metal tray being used on plenty of residential projects for sure.
More cost differences. Cost difference between the Nuratherm TPO and the 2-layer torch-on. Now, basically, square meter for square meter, the product is very similar. So a square meter of base sheet and cap sheet is very similar to a square meter of TPO when it comes to product costs. The savings come in when it comes to labour and installation. So a large square rectangular roof can be very quickly installed. There's not much detailing, so therefore would recommend TPO. Torch-on can be detailed much easier for a detailed project. All right. We've got a few more questions. I don't want to go over time because I appreciate everybody has signed up for half an hour. I think we've got time for one more. Does the warm roof build-up have any acoustic properties?
It does. Yeah, we do have a Marshall Day acoustic consultants report for the Nuratherm on metal tray, and the findings of that report in terms of acoustics. It has very good performance, so it reducing unwanted sound transmission from outside in. It's very good. And that particular report from memory is on the 3PM on the 2-layer membrane system. So yeah, it's very, very good.
Yeah, I think it gives an STC rating of 37, if I remember correctly.
Yeah.
Yep. All good. All right, folks. Thanks again for your time. At the end of this, there'll be a quick survey that pops up, and that's where you can put in your registration number for your CPD points. I've been Shane, Scott's been Scott, and thanks for listening to us.